Hello everyone and welcome to our third video in the Succeeding in 5th Grade Math playlist here. And today we're going to be talking about numbers and operations regarding fractions. So first of all, let's look at how to use equivalent fractions as a strategy to add and subtract fractions. First of all, you have to understand how to add and subtract fractions with denominators that aren't the same. There's a very, very important strategy that has to always occur when this is the case. First of all, you want to replace that given fraction with equivalent fractions. By doing this, you're going to produce an equivalent sum or difference. And what this means is if you have like denominators and you add or subtract them together, you will get a result that gives you some sort of equivalent sum or difference, but that can only be possible if you use those like denominators. So if we look at this example here, we're adding 5/12ths plus 1/20ths. Okay, simple enough. But now we have to find a common denominator where 12 and 20 will both go into evenly. So at first glance, you have to say, hey, 20 is the larger number, so let's try some certain factors, right? Let's look at 20. 12 doesn't go into 20 evenly. Well, let's multiply 20 by 2 and get 40. 12 doesn't go into 40 evenly either. So then we go 20 times 3 is equal to 60. Now 12 goes into 65 times. Therefore, we can go ahead and say our common denominator here is 60. Once we know that, we multiply everything so that the top and bottom equal 60. Here you can see we multiply 5 to the top and bottom, and multiply here 3 to the top and bottom. After this is done, we have a common denominator that is 60, and we just add the top and the other fraction together to give you 28 over 60. Once you have 28 over 60, just go ahead and simplify using simple arithmetic. In this case, we can divide the top and bottom by 4. So 28 divided by 4 gives you 7, and 60 divided by 4 will give you 15. Now, in addition, you have to understand how to solve real-world problems with addition and subtraction and unlike common denominators. So let's look at a very, very simple problem. We have 2/5 plus 1/2 equals 3/7. Obviously, we know that 2/5 plus 1/2 isn't 3/7. In fact, if you were to solve that out, it would be much larger than 3/7. The important thing to understand is that it can't be 3/7 not because we solve it out, but because we use common sense and understand that since 3/7 is less than 1/2, and we're adding 1/2 to the answer, and the number that's being added is already 2/5, we should quickly come to the realization that, hey, it can't be less than 1/2 if we're adding 1/2 to the problem. Similarly, if we're doing 2/5 minus 1/2 is equal to 5/7, understand that 1/2 is being subtracted in this problem. So 5/7 is greater than 2/5, right? And 2/5 is being subtracted. So therefore, there's no way it could ever be bigger than 2/5. Since the number 2/5 is only going to a smaller value, and 5/7 is a larger value than 2/5, you can use intuition and common sense to understand that, hey, I'm not going to be getting a number that's larger if I'm subtracting. Now, another important concept is being able to apply and extend previous understandings of multiplication and division to fractions. So this part here says, hey, can you interpret a fraction as division of the numerator by division of the denominator? So in other words, can you understand that A over B is really just saying A divided by B? To make this a little more easy for you to understand, let's look at two examples here. So 3/4 is the result of dividing 3 by 4, as we saw right here. Noting that 3/4 multiplied by 4 equals to 3. Okay, well, if I do 3/4 times 4 over 1, the 4 and 4 will cancel to give you 3 over 1 times 1 over 1, which is just 3. And then when those three wholes are shared equally among 4 people, each person has a share size of 3/4. Simple enough. If you have 3 wholes, okay, so you have 1, 2, 3 wholes shared among 4 people, that's 3 over 4 per person. So 3/4 times 4 for a total of 3 wholes. Okay, now let's look at a problem where they don't give us the answer and we have to kind of solve it on our own. So it says if 9 people want to share 50-pound sack of rice equally by weight, how many pounds of rice should each person get? Between what two whole numbers does your answer lie? Well, let's think about it this way. If there's 9 people and they want to share a 50-pound sack of rice, then what you have to do is divide those pounds equally among the 9 people. The way to do that is to say, I'm going to get the 50-pound sack and divide it by 9. So 59 pounds of rice goes to each person. To check your answer, you just say 50 over 9 times 9 people is equal to 50-pound sacks of rice. This makes sure that you have an equal distribution for each person. Now, 50 over 9, if we think about that as let's go ahead and make that a mixed fraction. Okay, 50 over 9. Well, 9 goes into 50 5 times with 5 left over. So you can write it in a mixed fraction as 5 and 5/9. Okay, simple enough. Now it's asking us between what two whole numbers does this lie? Well, 5 and 5/9 is really just between two whole numbers, 5 and 6, because 5 and 5/9 is, as we know, just 5.45, something like that. The main idea is to understand that 5 and 5/9 is lying before 6, but after 5. And you can see the answer down here. It's lying between 45/9 and 54/9. In fraction form, that's basically saying lying between 5 and 6. Okay, now we're also going to apply and extend our previous understandings of multiplication and division to understand how to multiply a fraction or whole number by a fraction. Now, there's a couple ways to do this, okay? Let's just go ahead and jump right into the examples, since that'll make the most sense for you. Now, the first example says, use a visual fraction model to show that 2/3 times 4 is equal to 8/3. Okay, well, we don't have a picture here, but if you would think about 2/3 times 4 equaling 8/3, you could really just think of a pie, right? A slice of pie and cut into 3 equal pieces. 2 out of the 3 pieces are filled in with, let's say, red, and the other piece is left blank, okay? Now go ahead and duplicate that pie 3 more times, so you have four pies total, with 2/3 red colored in each pie. Now, if you multiply that initial pie with 2/3 colored in by 4, that will give you 8/3 pie of 8/3 pie that is colored in. So that's how you use that visual fraction to show 2/3 times 4. Now, do the same thing with something else, like 2/3 times 4/5, okay? Now, let's just kind of solve this algebraically here. Well, 2 over 3 times 4 over 5. First thing you have to understand is I'm multiplying this 2 by this 4 to give me 8, and then this 3 by this 5 to give me 15. So you multiply the numbers on the top by the numbers on the bottom and create a fraction, which is 8 over 15. Pretty simple, pretty standard, but very, very important concept in multiplication and fractions. So in general, A over B times C over D gives you the answer, or A times C over B times D is basically what we did to get the final answer. Okay. Now, final part for this idea of applying and extending your understandings of multiplication and division. They want you to interpret multiplication as scaling by doing one of two things. First of all, you can compare the size of a product to the size of one factor on the basis of the size of the other factor. So what that means is if I have the product of one factor, right? Well, let's say I'm looking at, for example, 2/3, okay, of one factor on the basis of the size of the other factor. Okay, let's say 1/3. You have to understand that the product that gives you 2/3 is larger than the product that gives you 1/3. Okay, now something else. We have to understand why multiplying a given number by a fraction greater than 1 results in a product greater than the given number. Pretty simple to think about. Let's say we have 1/4 and we multiply it by 2. Well, we know that's going to give us 2/4 or 1/2, which is bigger than 1/4. Okay, and so on and so forth. Whenever you multiply a number bigger than 1 to a fraction, it's always going to be larger. Now, vice versa, right? When you multiply a given number by a fraction less than 1, that's going to create a product smaller than the given number. Okay, and what that means, if I have 1/2 again and I multiply by 1/2, that's going to give me 1/4. And we know 1/4 is smaller than 1/2. And it's super important to understand this relationship with fractions. A number that is larger will be a number that is larger than 1 will increase the total amount, and a number less than 1 will decrease the entire amount. But very interestingly, if you multiply just by 1, you're just going to get the exact same number. So just keep all of that in mind. Okay, one more part actually to this understandings of multiplication and division from the past. And this is a pretty simple one, but still very important. So essentially, they want you to understand how to divide fractions as well. That's what all of these things above are saying. And you want to interpret the division of a unit fraction by a non-zero whole number and then compute quotients. So let's just look at an example. If they ask you to do 1/3 divided by 4, okay, the strategy I will always recommend when you're doing fractions is simply multiply the reciprocal of the second number. Now, what that means is if you have 1/3 divided by 4, go ahead and make it 1/3 times 1/4. So all you did is flipped 4 over 1 to give you 1 over 4. So your new number is 1/4. Now go ahead and just proceed as you do usually, and you get 1/3 times 1/4 is equal to 1/12. Now, the second example here says 4 divided by 1/5. Pretty simple, except you're doing it the other way this time. So 1/5, flip the reciprocal, you get 4 times 5, because 5 over 1 is simply 5, and it gives you 20. And that's really what you have to understand about dividing these fractions. And that's pretty much it for Unit 3 of Common Core Standards, Grade 5. So I hope you guys enjoyed the video. I'm just going to go ahead and stop share now. And have a great rest of your day, guys. And I'll catch you guys later, hopefully, if you watch our Unit 4 video for Grade 5.